Let's look at learning objective B. We're going to compute values using what's called the continuous change formula. Now we just got done looking at this compound interest formula. And remember what Leonard Euler did is he said, what if we don't compound it monthly or daily, but we do every second? What if we did every half second, every quarter second? What if we did it continuously? If someone at the bank sat there and just kept hitting the button. If you do that, it approaches what is called e to the r power. And what we're going to do now is this formula changes. It changes to what we call the continuous change model. What you want to now know is when you hear that something compounded continuously, that's the key here, you use the formula A PERT. It's A equals P e to the RT. Now, the P value here is the same. The A value here is the same. The T is the same, and the R is the same. What we don't have to do now is on this one, we had to know how often do we compound it. Is it daily? Is it hourly? This one compounds continuously. So all you use is you use A PERT, and you actually use the letter E. So let me just show you on just one of these examples. If you take this component of the compounded formula, and then we compare it to this value of A PERT, they're going to do 5% interest compounded daily. So if you hit the button once a day for a year, what if you sat there and you compounded it continuously for 1 year? If you compare these values, here's what you get. There is a slight difference. This one is going to be the 0.051267. This one doesn't start to change until you get further out here for compounding continuously. So what this tells you is be careful on these problems. Don't round too soon. Do carry out your decimals. So let's go ahead and take a look at a problem that uses A PERT versus using this. So here we have $500 is invested in an account that pays 8% at an annual interest rate. Now, Part A says give the balance after 4.5 years if it's compounded continuously. Whenever you see that word, that means A PERT. So A equals P e to the RT. Now let me just read Part B to you. This one says, how does the balance compare with quarterly? So this means use the other formula. So we're just going to compare those. And let me write the other formula. We're going to do 1 plus r over n to the nt. So let's set that up. They're very similar in the setup. For compounded continuously, we are putting $500 in the bank here. It's E. The rate is 8%, so 0.08, and this is for 4.5 years. Now you do have to do order of operations, so it's e to this power, and there's a button on your calculator. It shows e to the x, so all you have to do is type e to the 0.08 times 4.5, and then when you take that answer times 500, you're going to get that you're going to have $716.66 in the bank. Now, how does that compare to what if we hit the button once a quarter? Well, it's just going to be at the $500, 1 plus our 8%, but cut that into 4 pieces. This is for 4.5 years, but we're going to do it 4 times a year. So when you calculate this one, be careful on the calculator. Do 0.08 divided by 4 and then add 1 to it. Once you have this value, raise it to the power of these two numbers multiplied together, and then times it by 500. So that means take the 1.02 to the 18th power and then times it by 500. When you do that, you're going to get that there's $714.12 in the bank. So there's not a huge difference, but it does make a difference in terms of how much money you get. Now who cares about this slight difference? The people with a lot of money. To you and me, when we go to the bank, we may not be as concerned how often they hit that interest button, if it's continuously or quarterly. If you have millions and millions of dollars, this is one thing you're going to ask as you invest your money, is how often, because this slight difference will add up over time. So let's look at another example. In this one, they are going to want us to calculate what's called the annual yield. And we end up doing it when we do the calculation. We just have to know where to interpret it. And what annual yield is, it's the percent of return made on an investment. So again, here is our compounded formula. Here's compounded continuously. Let's look at this example. $500 put in the savings account at 8%, compounded continuously, so we're using APERT. They want us to calculate the annual yields for just 1 year. So if we do that, we're going to do $500. It's E to the R, and T in this case is just 1. So when we simplify that, I'm going to actually put a few steps of work here. Let's keep the $500 there and just simplify the E to the 0.08. That's what we get. Now I want you to think back to what we did with exponentials. Remember this formula. This right here we called the growth factor. Within that growth factor we had the rate. So what we have here in just simplifying the APERT formula, we actually have here our growth factor. That is the growth factor. And within this we see that the rate is embedded. So this right here is really showing me the rate of return. If I move the decimal place, what you're going to see is it's 8.3287%. What that tells me as an investor is the bank said, hey, we're going to give you 8%, but if they compound continuously, I'm actually going to make more than 8%. Because they sit there and hit the button forever for a year, you're actually going to make 8.32%. So it's just embedded here in the factor. Now part B, what is the value in the investment? Just continue this calculation. If we finish this off right here and simplify, you're going to get it's $514.64.